Hello, Honors Chemistry. Let's get started with this mole practice quiz. So the first question we have here, it says, how many are a mole of anything? So we're going to use Avogadro's number, and we know that number is 6.02 times 10 to the 23rd. Now remember, we can use that number as a number of anything. So we can say it's a number of particles, it's a number of molecules, or we can even say it's a number of eggs or pieces of paper. Next, the next question is asking, how much does a mole of carbon dioxide weigh? We're going to use this and go and look it up on the periodic table. We're going to take our CO2, we're going to look up each one of these values on the periodic table. We find that our C is 12.01 grams per mole. Found that on the periodic table. And we know that oxygen is 16.00 grams per mole. However, we do know that we have two oxygens. So we're going to multiply this times 2, which gives us 32. Now we know both components. We should add them together to find what carbon dioxide is equal to. So what I would do, take 12.01 grams plus 32.00 grams. They're added together, and we find that equals 42.01 grams for every 1 mole of CO2. We're going to take that number now, and we're going to put it into the next problem. We have 150 grams of dry ice. We know that dry ice is just solid carbon dioxide, so we have 150 grams of CO2. We know that our end goal is to find how many moles there are in this. We're going to be doing some dimensional analysis then. Set it up like we're doing a table or a grid, and we know that there is, for every 1 mole of CO2, there are going to be 42.01 grams of CO2. We're going to take this value, put it into our calculators. I do 150 divided by 42.01, and I find that equals 3.57. I'm going to go through my problem now, and I'm going to check what I'm ending up with for units. My grams cancel out. I'm left with moles. So I have 3.57 moles. And we also need to know what the label is on it. Our CO2s here cross out, but we're left with this CO2 up top. Moles of CO2. Awesome. Now, next question. We're starting with 7.52 times 10 to the 24 molecules, MLCs, of CO2. We want to know how many moles are in this many molecules. So we're going to do dimensional analysis again. I'm just going to set this up like a grid. For this, we know that for every 1 mole of something, there are 1 mole of CO2, there's going to be 6.02 times 10 to the 23rd molecules of CO2. For this now, we're going to plug this into our calculator. We'll plug this value in. Let me open up a calculator. We're going to take 7.52 times 10 to the 24. We're going to divide it by 6.02 times 10 to the 23. And we find that it's going to be equal to 12.49. So we have 12.49 moles of CO2. All we have to do here We're dividing our molecules, crossing them out. CO2s are crossing them out, but then we end up with moles of CO2. The next question, we have 7.52 times 10 to the 24 molecules of CO2. In this question, it's just asking how many molecules this is. So if we look at this, we have 7.52 times 10 to the 24 molecules of CO2. In this instance, I could also ask you different questions like how many atoms of carbon this is. And we could also say, since there is one atom of carbon in this case, there are also 7.52 times 10 to the 24 atoms of carbon, just because there's only one. The next question, we're going to go into a little more detail with this. So we're going to start with 30 grams of dry ice. We know that dry ice is CO2. Starting with 30 grams. And we want to know how many oxygen atoms we have. So starting with our grams, we're going to need to take a couple of steps to get all the way to oxygen atoms. So we start with our 30 grams. We go to 1 mole CO2. We looked this up in our periodic table in the second question, and we found that for every 1 mole of CO2, there's 42.01 grams of CO2. We want to get from moles, we want to get to molecules of dry ice. So, 1 mole CO2, dry ice, there is 6.02 times 10 to the 23rd molecules CO2. But wait, there's more. We know that in this molecule of CO2, there are 2 oxygen atoms. So 2 oxygen atoms for every 1 molecule of CO2. We're going to take this and we're going to try and see what values we can cross out. Grams cross out with each other. Our moles cross out with each other. And our molecules cross out with each other. What about our labels? CO2, CO2, and CO2. In this case, we know that our units are going to be atoms of oxygen. We plug this into our calculator. We find that is equal to 8.60 times 10 to the 23rd. So, when we're going through these problems, make sure we let our units lead, and then our numbers will follow through. Units are leading, labels are leading, then our numbers will follow through.